Alright, Schulte, so let me break this one down for you. So let me actually break this down real quick here. Alright, so we loading the codecs up later. That's for some stuff we'll be needing. You'll see that before this one, hopefully. I want to make this bigger though. You bigger. You down, we'll get this playing. It's about G code and M code. Should be useful for the job if I'm gonna get it. That'll be
Hey,
useful.
what's up,
Hey,
everybody? This
still
is
good
Titan
learning.
from Titans of CN.
Titans of CNC. Now I've actually done him before, but this is a better presentation. Hopefully I can bring up a better index. Let me see if I can tighten him off just a little bit more here so I don't mess it up when I'm clicking. Alright, so G code and M code is an important thing to me. It's something that I talk about in the STEM and general relativity. I'm using him as the index, but firstly, let me notate something special from the differential. There is a marketing differential. I want it to be known as a neutrino. We're going to allow that function inside here. Understand, given the function, I would be happy if I needed the tool in which to be made to be done right here. More than likely, given the pay and the cost, me putting it in here, and what he'll be doing later with this terminal in terms of code differentials. Out through different boxes, I've been in, again, integrated wood components, saw factories, even individual job site quotes are a basic terminal of what we will learn while going through this system X, Y, and Z. And linearly, a lathe is a CNC, and it becomes that G code, M code stuff of get away from the top here, create a little space for it, the vacuum problem, derivatives, speeds, feeds, all that stuff that are appropriate for the matrix under that standard, which become a program under this that says trial and error limits it to this system, while that piece of equipment is in there, so it can be in program to that file, correct series of beep, 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 which are always the standard law if those functions come through to operate this standard. So what I was doing like cabinet doors and stuff with routers and drill bits and things like that. And it wasn't exactly a closed off table. There they had a vacuum table where the board was pressed, clamps come down, you pull it in, you take it out, you put it in, put it out, you do the hokey pokey, shake it all about, get it started up in the morning. Most of those programs were done for me, but I've done them in different systems. And like I said, programming a saw, a lathe, or a CNC, toe notcher position where you actually physically manual the what was called the CNC machine over there was the edge straighter. It squared off the 2 by or the plywood. And so when we get into this, you're going to get a lot of that feedback loop, but you don't really ever know. I would just assume heavily, given the shiny, that in there something relative. Um,
CNC, and in this video, I'm going to teach you how to manually program with G and M code at the control.
so firstly, ground code and movement code, or whatever he's going to quantify FMA to be, is what becomes relative in that form of the test of microfarads into into the capacitors to the battery, how long that rotational force will index without brakes or with brakes, or serviceability to feeds and speeds of bit times. And they become another program that is not autonomous to the movements and operations this thing can do, but will be relative to their amp limits, feed limits, um, cut windows, things like that, where it'll automatically shift over because it'll understand it's in material for that time, register its space, and those are a lot of programs that are designed in there to do it. Equally, like that doesn't matter, you could operate that speed at zero, and that's to say the connections of the feeds and speeds is an operation of CNC mechanics, quantum space, where the field theory works equally given derivatives and coefficients. If you can map that graph, give it velocities, voltage, amperages, resistance, any kind of deformation principles or plasticity, polarizing models, or G code, they're in the file cabinet. Maybe they are the bits in this case, 0 and 1, the bits, if they are bits or bits.
So I figured to teach G and M code, one of the best ways to do this is to actually write a program and then explain what I'm doing so you can see how the codes react to each other. Also, I figured I'd pick a project that was familiar. So right here,
It starts with a 90-day Master Mason challenge. There will be a basic test on what to do for the basic operations. And that'll be whether it's today's, that's what the chip we're doing, or what limiting factors before cutoffs come into here for some sensor to come check that if this was the machine housing. No matter what that is, that becomes your lawful orders under time work fraud cases at that point to say they weren't going to expect anything more from you. They cannot expect anything less from you. And at that point in time, this becomes that operating standard. That would be you they're making you as the first piece of steel there, because they don't know if it's iron, they don't know if it's titanium, they haven't run the tuning fork against it yet to really figure out what kind of composition it is, but generally it's human in this machine.
I have the Titan 1M from our academy, and we have 3 different prints that take you through the stages. So the first print shows you the outside
Well, in the safety of the G code and M code here, this being program, I need this to cut out here. This could be quantifiable as a test, but there's pretty serious indicators for them to make the realization of that next piece or any other prior piece could have been this, has to be this formation, look like this, something very similar to this if any other piece. And so G code is all codes. G equals the square root of M1 and M2. Reverse engineer it, X, Y, and Z. I like that. Change its size on a matrix, adapt it into the system. But this is a block of steel, right? Or aluminum. What can you do with it? Where can you put it on a thing? If the limitations were to just square it up to that, well, that's a fine value. That's a fine thing to say. But for me to make the determination of which one of those in the patent design office is a pretty extreme case of things that you need. I mean, even the fact that it needs to be those are 2 different types of, well, I can carve that out of everything. Statues and, what is it, Da Vinci there talking about the baby that he carved for the archdiocese that found out that it was a replica of something from Rome because he actually had the tool, that thing that comes over and marks all the pieces so you can actually hammer it, isn't just the free hand carving it out of the universe. That isn't the same thing, and this is, somebody made a choice to limit it to the faculties of this operation has standard models. I mean, and give it a block of steel, I'll figure out whatever you want it to be, but just to say I'll carve a block of steel to figure out any problems, a little different.
That you have to machine. The second print shows you the 1032 threads inside the part, and the third one shows the pockets and shows the part complete. So let's actually profile the part with a 1/2 inch end mill and come back and actually chamfer, drill, and tap the 1032 threads. One thing I'll also say is G and M codes, what are they? G codes actually create action. It makes the machines move. M codes usually turn things on or off. So to turn on the spindle, you hit M3, spindle turns on. Turn on the coolant, M8, shut off the program, M30.
They all can't be Marlar. Back to the steel.
And on and on. So G codes create movement. M codes turn things off and turn things on. So now the first step in programming is to actually create a program. To create the program, I'm going to hit list program. I'm going to hit O. All programs start with the letter O, so I'm going to hit O. I'm going to look up and see the different programs in there and pick a number that's not being used, and I'll pick 300. I'm simply going to hit enter.
Well, some of that information may be useful.
There it is. From that point, I hit memory. Boom. It sets over here. I hit edit. I'm able to toggle around and actually create my program. So the first thing I'm going to do is create some space. This end the block key right here is genius. So I like just kind of hitting it, boom, boom, creating some space, getting away from the top. This is where
that was a note I really like to reference here. Get away from the top. Like I said, when I've done this in different places where I had to actually program those numbers to mean something on a saw program, to say that the turn off water first has nothing to do with the saw program. If you miss it, you will keep going back and back and back to this. You got to get away from that housing of the box of just like right in there, get away from the start of it a little bit. Maybe it does this indicator, and I would see that. Press go right now on your droid, and that'll move it away from the screen. That's all it'll do. It'll move back, but maybe not, but if you automatically program that, there's an incident where the thing that you don't want to have happen is what you want to have happen on this drawing, right? Dot, dot, dot. And so we want to get away from that to say that just this stone mill has its own code. And that's what the problem with G code and M code is. But there's but one physics, but you can only call them one thing. So in terms of training, observations Hubble, fair enough, it was a different building inside of there about, well, I needed this, you're allowed to camera this. Trainees, you should come in on a clean day where it's not totally foobar unless it's absolutely out in the field of a field, and then nothing's organized anyways. Where you could say, what I expected you to do in training, get out your cell phone, whip it out at me, I shouldn't be doing anything, pause. Those are exact orders. You could send them back to anything. Why there would have been any difference here shouldn't come up. It would give to pressure and a realization of, well, if that comes up later and I don't have that squared away, I would have been right on it and left it autonomous to the play. Get a little space inside of there so you can actually handle that program. That's not for everybody. There are other ways in which to do that. Sometimes multi-step operations where it is not just a test or a challenge to do it where you got to have somebody handy, but you want to reduce that time that person is there training with you, but make sure that you emphasize on the fact that this is a training regimen. I can't skip steps on that training regimen, and I have to go through a checklist on all of those things, because that's generally where it would have been missed. It would have been the said thing, they are moving real fast, you leave them alone, quit the training, hope they learn on it, and then their third shift working alone, you can't get in the office because there is no keys for the sensors on the saws, and you're trying to keep everything rolling. Makes for an issue. If you didn't have that regimen trained into it and other system sets or some way to manage that program, then of course that problem is going to pop up.
Where I can write instructions, XY0 is upper left, Z0 is top, move in, do this, do that, these are the tools. That'll all be right up there in my header. Now, to program these different tool paths, I'm going to actually use 4 different tools. And I'm going to pull those tools off of the building blocks tool list. It's a standardized tool list.
So remember, this is a custom piece of machinery apparently. And with that, there would be a very custom schematic about the incident report here. 3-inch face mill, milling inserts. So those are the names of the incidents, the name of the person, the name of the inventor, patent design, any of these numbers where that's going to correlate into anything. And that's why it's all Fermilab, because which particle name at what time on function on certain systems as it's passing through the keyhole.
16 tools that allows you to make all of the building blocks. So the first tool is tool number
standard
2.
model.
It's a 1/2-inch end mill, and we're going to use that
Well, they'll give you an order of a piece that they give you replicated to make. And not only is this piece the first thing, once it's done, that G-code movement should substitute this without too much stuff where I, as another brother, have to make the mitigation because he is in large momentum making quantum steps in a direction for a thing, marketing, CNC, physics, G-code, M-code, how do you cut it up? So in there, like I said, they'll give me a standard model of options in which to choose from the tool cabinet. Now as a sawyer, it doesn't usually come up because you'll have this blade or that blade, and really you don't have a lot of limited options between what a square rock is or how to use a blade, change the table axes around. That this does as its larger function that you could put a bit to. But then, like I said, is it rounding it off? Well, an end mill will help you out quite considerably with that if the area of it or the series of steps where that come in, or maybe you want a hogger bit or something like that if that was in there, and you just want to the steel that it comes in, I have to make it from is a wide area, and you hog out the middle of it with or use an end mill. Just use an end mill. And if that would be the common thing, most commonly, but then other options, patterns, and end mill cannot, will not, absolutely. Well, that's what number 2 on the test was for. And
that 1/2-inch end mill to actually profile around this part right here. All right, so now let's actually write this program. So the first thing we're going to do is we're going to hit M6. Go grab a tool. Let's do.
Well, it's nice when it's steel. It's like I'll put a brick in on my component. There might be some crib depths, I'd imagine, and some boards that had a crack in it, but particle board should be all chewed up into something. If it's not square, push it through the machine, then it's right into there. Click hone, make sure it's honed on a micrometer. Bluestone, no. You're going to have the end of the block, the middle of the block with jack in it, a run of jack that's on a 6-foot rock where I got to cut 3-foot sheets on it that slide through the middle of it, where I'm cutting 2-foot sections off on one end of it, 3 foot on the other, with a line running through it, reed inside of it where it was a block, and then I'm cutting it off into 2-inch sheets, putting them on the table where I have to read all edges. Otherwise, the 6-footers I try to cut out of there not only is a bad cut, but I'd have to cut it again. You know, it's one thing to say I took a gamble on a 4-footer or a 3-footer where I can't cut it down past treads anymore and I'm running stacks of treads. You know, kick it to the garbage, we'll count that as lossage inside of their X, Y, and Z for the function. But, you know, when you're running CNCs like that, it doesn't really matter. Wrap it on the pallet. We're all talking about efficiency and the systems, how many you can do by lunch, and that should be mechanical law. You know, if the order doesn't change or the first program does, I mean, you might have a little hitchies. A plus B equals C. I did it for the first day, maybe the back or the photons on whatever, but the second day was about the same number. In that same working ratio, feeds and speeds, not to overwork the bit, because you can say a brand new bit, just bulldoze it and lose that bit. And I know that from running wood, you know, running the drill bits, doing the thing, carves them out, burns them out. You know, but that was their program set. You know, there could have been just my numbers given other players because I put out an extra set because I was quick on the turns. Wrapping pallets was a little different. So, you know, when that does ticking the stuff out, some people stand there for 5 minutes ticking it out. Me, I'm click, get it in there, onto the next one. And, you know, that can make a differential on why you burn out more bits than somebody else. It might be one, but that would be that one that would be odd over a week when you're just hammering through stuff or whatever that angle is going to be every few days or something. Like, they don't tell you that number. You should burn out with this because they don't watch your standard model. And if they don't watch your standard model, they're not going to get an indicator on how to test that bit or change the feed and speed, G code, M code on what that is.
Do tool 1, and then we hit end of block, enter, M6T1. You see the 0? If you hit M6, the machine will automatically put the 0 in. You don't have to hit M06. Just hit M6, T1, end the block, enter, or just enter, and the...
Well, I need that goal. Like I said, in the failure points inside here, if you didn't do that, but you're like, oh, well, that little thing wouldn't matter to all the rest of this, I have to put into the computer on the other hand.
0 will automatically appear. So this is telling the machine to go get tool number 1, which is our 1/2-inch end mill.
Got it.
Next thing
It
we're
happened.
Do
You recorded me.
We're going to go to location. So we're going to say XY0 is in the upper left. So right up in this corner right here. All right, so now that we have
I
our
made
tool,
beautiful stone
we're
mills.
gonna
I
go
can
in,
walk out
we're
there
gonna say
shoveling
G0,
mud puddles and make it
rapid
good.
movement, move as fast as you can with no feed rate.
Right.
Let's
I
get
think we
to
know where we're going. This is a
position.
good video. I
Then we're
recommend
gonna
it.
hit G90.
Go get your parts
It's just a
custom made
safety
over
code
there.
that I like